Assalamu alaikum and hello everyone. I am Naushad. Welcome to my very first AI study jam session. Today we are going to learn how machines can actually see and recognize handwritten digits using machine learning. Don't worry if you have never done machine learning before. By the end of the session, you all will build your very first machine learning model using TensorFlow and Keras. To start, a quick questions for all of you. How many of you have written digits today? Imagine a computer recognizing them just like a human. Exciting, right? Our goal today is to understand the basics of machine learning, see the datasets, build a simple neural networks, train it, and evaluate its accuracy. So let's start with some theory. So basically, this is Geeks for Geeks website. So in machine learning session, according to Geeks for Geeks, machine learning is a branch of artificial intelligence that focuses on developing models and algorithms that let computers learn from data without being explicitly programmed for every task. Uh, for me, uh, theories are so boring. So let's simplify this uh, theory or the definitions from Geeks for Geeks. So according to me, machine learning is a system that learns from data instead of following hard-coded rules. For example, handwriting recognition. Instead of writing rules for each possible way to write a digit, the computer can learn pattern from thousands of examples. A the dataset we will use in this session is called MNIST, M-N-I-S-T, NIST. So NIST basically contains 70,000 images of handwritten digits, ranging from 0 to 9. Images is 28 by 28 pixels grayscale, and the dataset is split into 60,000 training images and 10,000 testing images. 6,000 training image and 10,000 testing image, remember. So this is what the model will learn from them and then test its knowledge on. So now let's briefly look at the workflow of a machine learning project. So okay, so it's gone. Okay, so basically for this entire project we separate our workflow into some steps. For example, uh, first we will load our data, then we'll pre-process it. Then after pre-processing, we'll build our model. Then we will train it, and then evaluate its performance, and finally use it to make prediction. So machine learning is iterative. You have to remember this, that machine learning is iterative stuff. So which means we try, we evaluate, and improve continuously. So we will use TensorFlow and Keras for this. TensorFlow is a powerful library for machine learning and deep learning, and Keras is a easy to use API. I think all of you know about API. So if you don't know about API, just go to Google and search it and know what is API actually mean. So we will use API here that helps us to build models quickly and efficiently. So okay, let's move into coding session. So please open in Google Colab, which is absolutely free in your browser. Which is free and requires no setup. First, we'll import all our necessary libraries. So look here, this is my Google Colab and I coded already and tested it. So uh, here we import all of our like libraries. First we import TensorFlow STF. Then from TensorFlow we import MNIST, which is our main dataset. Then we from models we import sequential. From layers we import Bayes and flatten. From Keras utils we import categorical, and we import matplotlib for visualization, and we import NumPy. So here the sequential is for building. The sequential we have import from models is for building a simple model layers by layers, and then we import dense, which is for fully connected layers, and we import uh, then we import matplotlib for visualized data and numpy for numerical operations, obviously. So let's run it. So we have just so okay, our libraries are done. Then we load the MNIST dataset here. So we actually import the dataset we will use here. So MNIST is imported successfully. So let's run it. I'm going to add this course, like maybe I will upload into my GitHub and then share with you in the description section or the pin comment. So then let's here okay, done. So normalization scales pixels values of okay to 0 to 1 for faster training, and 1 hot encoding converts levels into vectors for 10 classes to see what an image look like. Okay, for going to this session, let me explain this. So basically here we normalize our like pixel values here for faster response. So done. Then we plot the first training image here. So let's run it. Okay, done. So here you can see the computer sees the digit 5. Actually, what does it means? uh, when we give an input, computer is 5, like digit 5, the computer sees it like this. Okay. Then now let's build our first neural network here. Sorry. So let's build our first neural network. So we wrote this code where the flatter converts the 2D image into the flatter, this one, converts our 2D images into 1D vector, and then 128 ReLU uh, is a hidden layer to learn patterns, and then 10 comma softmax gives probabilities for 10 digits. So let's run it. Okay, done. So in the next step, we will like compile our model. So let's compile our model. Done. Then in the next step, okay, before going to next step, let me tell you something here. The optimizer this decides how the model updates weight and the loss functions, measures errors, and metrics tricks performance using training. So it's time to train our actual model. Let's train our actual model this. Okay. So epoch means approach. Remember this if you're a beginner. So our model is training into 5 approaches or epochs. So basically, epochs are fully passes through the dataset. Batch sizes, the number of sample processed at a time, and validation speed sets aside some data to check performance during training. So you will notice the loss accuracy decreasing and accuracy increasing here. Okay, so let's wait. Okay, uh, look at this. These are loss, these are accuracy, these are value accuracy and value loss. Okay, so let's compare. When we are in first approach, our accuracy was 0.8755 and loss was 0.4406. Then second step, it increase, and increase. Okay, so decrease, increase, sorry, decrease. Okay, so that means the more approach we use, the more accuracy we'll get and more losses we'll find. Like our model will do less losses. Sorry. Okay, so then after our training is done, then we should evaluate the model on the test set here. So let's run this code. Okay, so the test accuracy is uh, about what, 97.55%. That's impressive for a simple model, right? So finally, let's make predict on the first 5 test images and compare the actual level. So let's run this. Okay, we get so predicted is 72104 and actual was 72104, right? So basically this shows how well our model has learned. Okay, so to wrap up today we saw sorry, so to wrap up today we saw how machine learning works. Build a simple neural networks, train it, and evaluate its performance. Machine learning learns from data. That's what I said before. And TensorFlow and Keras makes it bigger value. So I encourage all of you to experiment by changing hidden layers, sizes, epochs, or data or batch sizes, and see how the accuracy changes. So I will upload this code into my GitHub, and then I will share it into my description, or into my first comment of this video. So thank you for attending, and I will see you in the next session. Assalamu alaikum. Allah Hafiz.